All right, after we finished talking about casting processes, now we're going to get into molding processes. And again, typically molding is being referred to when we're talking about plastics or composites. And the molding is the term that's used. So, our material here is generally not molten, but it is in a plastic or a softened shape that allows for the material to be shaped. There are three main molding processes that we're going to talk about and uh, go over here today. So, if you think about all the stuff that can be molded, of course, we're talking about plastics, we talk about ceramics, a lot of your glassware might be molded, soaps. That if you think about your bar soaps, those are molded. A lot of food products might be molded as well, um, in terms of getting the shapes that are out there. If you stop and think about plastics, you'll remember from chapter 9, we have those thermoplastics, we've got thermosets, and we have elastomers. And we have to kind of consider those different types of plastics here when we're talking about the molding process. So just as a reminder, your thermoplastics can be reheated and remolded over and over again. If it's a thermoset plastic, they're one and done. So if you try to reheat those, that generally destroys them. And then, of course, your elastomers are and your rubbers are things that can stretch and return to the original size. So, one of the common molding processes is what we call injection molding. So, this will take and inject liquid plastic into a cold mold at high pressure. When that plastic then cools, it gets ejected from the mold. And this is the main process for shaping thermoplastics. So, as just like before, when we were talking about the um, material and casting for metals, I've got some examples that you can watch on YouTube of these different types of processes as well. Rather than doing that here in this particular lecture, I will let you go back and go over the PowerPoint, and you can call those up when you do the PowerPoint. Blow molding is another common molding process. In this case, it's used for hollow parts. So a lot of your bottles nowadays, your water bottles, your um, milk bottles, Pepsi bottles, and any of those that are plastic are basically blow molded. And you get a tube that is kind of melted thermoplastic, and then that particular tube is placed into these molds, and you get air that is blown into them to fill the inside of the tube and basically press the plastic up against the walls of the actual mold. So it's kind of similar to blowing up a balloon. And of course, I just mentioned a couple of examples, but I'll let you try to sit there and think of some other examples besides what I've already given you. Here is an example of the blow molding process as well. Then we're going to talk about compression molds and compression molding. This is used with thermoset plastics. So if you remember about thermoset plastics, they are one and done. So it's only one time. Oftentimes these are plastic powders. Those powders are placed into the heated molds, and then pressure is applied in some way to kind of press those powders and change the chemistry to where they will be um, molded into the actual part or shape of the mold. So this combination of heat and pressure is used to harden plastic. Composites and composite materials are uh, formed similarly to this, but depending on the material properties of the composite, they may be hot or cold worked based on those properties. If we are talking here too about molding ceramics or other materials, ceramics and glass can be injection molded, it might be blow molded or compression molded. Usually, again, it depends on the actual type of material properties that are there and that are required for art. So again, the raw material usually starts as a powder. So, and there are, if you think about glass blowing, for example, you probably are all familiar with some of the different local artisans that do glass blowing. Here in Central Illinois, we have several different places that you can go to and actually see glass blowing demonstrated. Prairie Fire Glass in Monticello is one that I can think of that often gives demonstrations, or if you go there at special events, you can see them. But a lot of different craft fairs and so forth that you might be able to go to see local artisans do glass blowing and demonstrate glass blowing as well. Here are some of our companies here in Decatur that do molding for plastics and composites. So we've got Green Valley Manufacturing. Not so much molding plastics and composites, but they make a lot of products that go into the mold industry. So we've got Indelco. There's a company called, of course, you've heard about Ring Container. There's a company up in Clinton called Technoplex. All of these do different types of molding plastics. And if we go beyond Decatur, Central Illinois has several companies that make these type of molded products and parts, including CBM Plastics, Midwest Molding Solutions. Over in Champaign, you've got Plastic Pack and Silgan Can that are extremely large scale packaging companies that make this. And of course, Urbana, although they've Solo Cup used to also be one of the manufacturers over there in Urbana that would make and use plastics in forming the Solo Cups. I think they have ceased and are no longer making the Solo Cups there in Urbana, though. All right, lastly here, we're also going to talk about forming processes. There are several forming processes that we're going to mention. These processes include forging, extrusion, thermoforming, which you've all been familiarized already with some of the thermoforming activities we've done, hydroforming, forming powdered metals, and metal rolling and stamping. So if we define metal forming, forming basically uses physical force to change the shape of the material. And that force is generally applied either by hammering, striking, rolling, bending, or applying some type of pressure. So these materials can be either hot worked, which is known as hot forming, or cold worked, which is called cold forming. And all of these processes use some type of a die or a die set to help to achieve this. Forging shapes metal by hammering or pressing the metal into a certain shape. So if you think about the show Forged in Fire, and of course if you think about the old traditional blacksmith that would have a fire pit basically and some bellows to kind of blow air and increase the heat in the metal, and then the anvil and some big different hammers and forging dies there. So we're talking about that type of craftsmanship here, but we're also talking about this on a mass production type scale. So dies are used, and basically the die has to be a harder material and a stronger material than the material that we're pounding into that shape. Or the dies at least need to be able to have and resist the temperature changes that are required of it. So your material temperatures do vary greatly and can affect our ability to forge different materials. So it is important that a good understanding of chemicals and chemical structures can be important to forging, as that also changes the metallurgy and changes the chemical structures on those metals. When we talk about forging, it can also either be an open die or closed die there as well, and you can read the textbook to learn a little bit more about the differences between open die or closed die. We're talking here too about extrusions. So if we're talking about this, extrusions basically, if you think about like when you used to be a kid playing with Play-Doh, there were different types of plastic dies in a press, I remember that you could kind of shove the potato or shove the Play-Doh in to one end, and then you could press it through and get different types of shapes through a piece of plastic. So think about your cookie dough sometimes, or icing if you're using some of those to make stuff. Those are kind of example of extrusions where we're extruding material to kind of force different types of shapes. These extrusions might be solid or they might hollow, so we can use lots of basic shapes and get those basic two-dimensional shapes out of it. It's a very common way for us to process steel bar stock. So if you think about the ways we actually make steel bar, we can make round stock, square stock, hexagon stock, octagon stock. We can make a lot of different shapes in our bar stock based on these types of dies that metal is kind of forced through. It is also a continuous process, so as the equipment and raw material usually does take a long time to set up and prepare. So once it gets started, you're generally running it pretty much round the clock, and you typically don't want to disrupt those processes or have quick changeovers when you go from, say, one shape to another. Thermoforming, again, you've had some experience with this. We're taking flat sheets of plastic and we're forming it through the use of heat, where we heat up the plastic and more or less use a vacuum or some other type of way to apply pressure to that plastic to draw it over and shape it over the actual mold to force that over there. So it's widely used to produce plastic signs and other types of packaging materials. Hydroforming is similar to thermoforming, only here we use pressure, fluid pressure, and a die to shape the metal. And it's important to note here that it's a very, very high level of pressure that's generally required for this. So it's kind of an extreme case in some methods. So it's used to produce car frame railings and some other types of components there too. Talk about forming powdered metals. If you think about all of your inserts that are used in the metal cutting industry, a lot of these start out as a metal powder. They're kind of the powder is put into the molds and pressed into these shapes. We can get lots of intricate shapes formed here too, and generally then once those metal powders are forced into those shapes, then it also requires hardening in a furnace after that part forming too. And again, we call that sintering on that process. We talk here about metal rolling and stamping. And there's several different things that are going to be going on here. When we're rolling a part, we're basically squeezing metal between sets of rollers to either thin it out or elongate it. When we talk about round metal stock, it can kind of be necked down to smaller sizes. If we're talking about flat metal stock or metal plate, that can be rolled and be made either thinner, or it can be rolled out to make a certain plate diameter or plate size in terms of thicknesses and heights there that are needed. So stamping is generally a term that's referring to cutting that sheet metal after it has been rolled to the thickness that it needs to be rolled to. And we have four processes here for metal stamping. We have shearing, which cuts the sheet metal into a blank. Punching, which is used for holes or slots out of sheet metal. Drawing will take the sheet metal and draws that either over a die or draws it into a die cavity. If you think about your aluminum can bodies, they are typically drawn over a mandrel to get that. And we can also talk about bending, where we bend the sheet metal into different shapes as well. Other advanced processes here that we could get into, it's important to note manufacturers are constantly trying to improve or achieve greater efficiency, lower cost, and reduction in waste. And in order to do this, Um, there is a movement in industry to try to eliminate processes where it is possible to eliminate those processes. And to do that, we can either improve castings and molds, um, and we call that net shape manufacturing, basically where we can